Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of slope as unit rate. This is standard 8.4b in the great state of Texas, and we are using item number 42 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got an oil well contractor drilling a shaft 7 meters deeper into the ground every 2 hours. So that's our rate right there. 7 meters deeper into every 2 hours. And which graph has a slope that best represents this rate? Well, let me see. 7 meters deeper, you notice it's negative. All of our y-axes are going to be in the negative because we're drilling down. So they give us this rate of negative 7 meters over every 2 hours. And so if we wanted to turn that into a decimal, right, we could say that's negative 3.5 meters per hour. So drilling down, negative 3.5 meters per hour. So how do we calculate slope? Well, remember our slope is rise over run. So that's how we remember the change in y, because that rises up and down, in this case down, over run, because x goes side to side. And so really we just need two y coordinates, we're going to subtract them, two x coordinates, we're going to subtract them, make sure we put our y in the numerator and our x in the denominator, and we're looking for something that's going to give us this unit rate as a slope of negative 3.5. And as we can see, F, G, and H all look pretty similar. The difference here is going to be in our y-axes. You notice that they use different scales here. The x-axes look similar. They all just go from 0 to 10, except for J. So let's just talk about J. J doesn't work. J has no slope. Remember, that slope is the rise over run. You notice there's no rise. Doesn't go up, doesn't go down. It stays as an even depth of negative 3.5. So you cannot calculate that, or it's got a slope of 0 actually, simply because it doesn't rise or doesn't fall. So it's not going to be that. So we're down to F, G, and H. So let's take, you know what, let's just take this coordinate right there, because maybe I can use that one. That does look like it kind of crosses right there, but the rest look like they're super close but not quite on an intersection of an x and y. So I'm just going to use this one just to be sure. So that is 10, negative 20. Now, to be smart, what I'm going to use is I'm going to use my origin. This is a proportional graph as my other pair, and see what happens when we get into our slope here. So it's negative 20, right? Our two y coordinates, minus, I'm going to use the origin, 0. Over x, 10, minus, I'm going to use the origin, 0. Well, negative 20 minus 0 is just negative 20. 10 minus 0 is just 10. So when you're calculating slope, if it goes through the origin, use that. And you could just take the x and y coordinate and put the y on top, and you actually got your slope right there. So negative 20 over 10 is the same as negative 2. So I'm looking for negative 3.5. At least it's negative, but it's not quite there. I'm going to do the same thing for this right here. So that is, once again, x of 10. The y is negative 70. Yikes. I'm going to use the origin as my other pair, so that's going to make it super easy. So I'm going to do my y of negative 70 over 10. I could do a minus 0 if I need to, but there's no real point. It's going to give me negative 7. Close, but I hope I've got it here. All right, so this one doesn't go all the way down to the bottom right-hand corner. This goes right there between, looks like the x is 10, the y is negative 35. So I'm going to get negative 35 over 10. Aha, that's looking pretty good. When you divide by 10, you just move the decimal over 1, right? So look what I get, negative 3.5. So that's looking good right there. My answer here is going to be H.